Hello everyone, I am Naveen Kumar S from the Department of Computer Science and Engineering, Saveetha Engineering College. Today I will be presenting experiment 3 of interfacing an IoT development board and configuring USART for transferring strings. The goal of this experiment is to establish serial communication between Usart between our STM32 microcontroller and a computer. So here the components required are STM32 Cube IDE software, ARM IoT development board, ST-Link programmer tool, serial port utility tool. Before going into the steps, let's understand the theory. ARM is a 32-bit microcontroller architecture widely used in IoT and embedded systems. It supports efficient instruction execution and low power consumption. USART stands for Universal Synchronous or Asynchronous Receiver Transmitter. It is a serial communication protocol that allows two devices to send and receive data asynchronously. That means there is no shared lock. Both devices must agree a baud rate, for example, 9600 bits per second to communicate properly. Let's move on to the procedure. First, open STM32 Cube IDE, click File, New STM32 project, select your target board or microcontroller, then click Next. Name your project appropriately. An IOC file will be generated automatically. Configure the required pins. Select one USART interface, for example, USART2 underscore TX and USART2 underscore RX pins. Save, save the configuration using Control S, which automatically generates the code. In the main.h file, edit the code to send strings through UART. Build the project using build all. Open STM32 Cube programmer, connect your board and flash the ELF file. Finally, open the serial port utility to view the transmitted data. So here is the 32, STM32C program used in this experiment. The printf statement sends text messages to the serial terminal. The HAL underscore UART underscore transmit function handles the actual data transfer. After flashing the program, I opened the serial port utility tool and connected it to the correct COM port. The output successfully displayed the transmitted strings. Saveetha Engineering College SCOFT, repeating continuously with a 500 ms delay. This confirms that USART communication was configured and functioning properly. Result: thus, the IoT development board was successfully interfaced and the USART was configured for serial communication. The transmitted strings were verified through the serial monitor, confirming proper data transfer. This experiment demonstrates how to use USART in embedding systems for reliable data transmission.